All right, so last week we were talking about the kinematic equations, the four motion equations that you're going to be using throughout the whole year. You know, every topic that we're going to look at in physics involves some form of motion, and these are the equations that can be used to, solve for displacement or velocity or acceleration. You all know that you have to memorize equations for the quiz, so I'd memorize these sooner rather than later. And the only thing I want to make clear, and we talked about it last week, is that x, in these equations, x is a displacement. So technically, how should we really be writing this? As x or as delta x? I mean, technically, it should be delta. I just write it as x, as do a lot of physics teachers, and even physics books, will just refer to it as x. Which technically speaking, x is a position. So just be aware that x is a displacement. And the example we did last week of x being a displacement, we talked about a guy on top of a building throwing this ball. So if he throws the ball up, the ball goes up, 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 and then down, 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 right? And then lands down here. The displacement of the ball would be, it's always from starting point to ending point. So this distance in here is the displacement. Does that make sense? The shortest distance from starting point to ending point does not care about that. Does that make sense? Okay. All right, so let's do a kinematic problem. This problem here is super easy. You'll notice that the way I like to teach is I start with the basics, like we'll do real easy stuff to begin with, and then as we move farther into the chapter, it'll become more challenging. And the homework set's that way as well. You'll notice that there's easy homework problems, and then there's homework problems that are going to make your brain sweat, which is why you don't want to wait till the night before. The Chapter 2 homework set is due next Tuesday. If you wait till Monday night to start the homework set, that's the worst thing you can do. I like the analogy that learning physics is a lot like learning a musical instrument. How many of you play some sort of musical instrument? Only like 5 of you? Okay. So those of you who play a musical instrument, is it better to play your instrument a little bit every day or once every 2 weeks for extra long? A little bit every day. So I think it's reasonable for AP Physics to be spending minimum 30 minutes a night, and then as a quiz or test gets closer, you'll spend maybe 2 or 3 hours on one particular night. Okay, so I'm going to give you guys a couple minutes. This is an easy kinematic problem, so just see how it goes. For every chapter, beginning with chapter 2, what I want you guys to do is do a diagram for the problem. So here it's a car accelerating from an initial velocity of 2 meters per second. So do a quick sketch, doesn't have to be artistic, of the situation. And the reason you want to do a quick sketch is so you can label your given information. So the initial velocity of the car is 2 meters per second. The final velocity of the car is a question mark. We don't know. The acceleration is given as 3 meters per second squared. And the time interval from start to finish is 4 seconds. And then the displacement from the starting point to the ending point, the displacement is also a question mark. Okay, so the first question is, what's the displacement of the car? There's only one of the 4 equations that we can use to solve for the displacement with the given info. The only equation that's going to work is which one? The first one. This is the only one, unless we solve for velocity final first. If we did that, then we could use 3 of the 4 equations to find the displacement, if we know the final velocity. Remember, there's not just one way to do a physics problem. a lot of times, if a question has part A, B, and C, you could do part C and then go back and do part A. Whatever route you want to take. There's no right or wrong. Okay, so using the first kinematic, so x equals 1/2 at squared plus v initial t, we're going to get, so the acceleration is 3, the time is 4, the initial velocity was 2, time is 4. This gives a total displacement of 32 meters. How many got that right? Nice. Good job. Okay, second question. I'll do it over here. The velocity of the car at the end of the 4-second interval. All right. Now at this point, you could use 3 of the 4. Could you use this equation to find v final? Yeah. Could you use this equation to find v final? Yeah. Could you use that one? Yeah. You could use 3 of the 4. I think the easiest one is this guy here. Vf equals v initial plus at. So v initial was 2. The acceleration is 3. The time is 4. So real easy. I just want you guys to get to feel really comfortable with how these equations work. So v final comes out as 14 meter per second. So any questions about the motion equations at all? All right, so let's look at a very specific situation, a very specific physics situation, referred to as free fall. So free fall problems, I want to start by talking about what does the word free fall mean. The definition of free fall, an object is in free fall when the only force acting on it is gravity. When the only force acting on an object is gravity, the object is said to be in free fall. And in chapter 2, for the entire chapter, we ignore air resistance. It's a very common thing. Kids will say, oh, but what about air resistance? Because does air resistance exist in real life? Yep. But in chapter 2, when you're doing all these kinematic problems, ignore it, okay? So look, here we have a kid throwing a ball up in the air. We're told over here that the initial velocity is 8 meters per second. The ball goes up, 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 up. Now, as the ball is going up, 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 is it in free fall? It is, which is why I'm making this real clear. It's kind of weird to think of an object going up as being in free fall, because free fall has the word fall in it. What does fall make you think? Down. But just be aware, an object can be going up and be in free fall. Because what's the only force on the ball as it's going up? Gravity. That's the only force on the ball, so it's in free fall. Okay? There are 3 things that you need to know about an object in free fall, and I have them listed right here. The first thing is that the velocity at the highest point is 0. So the ball starts with a velocity of 8 meters per second, and as it goes up, what happens to that velocity? It gets smaller, smaller, smaller. When the ball reaches the highest point, the velocity is 0. Now, will problems tell you that? When you're doing a free fall problem, is the problem going to say, oh, and the velocity of the ball at the highest point is 0? Are they going to tell you or expect you to know it? You got to know it, right? I call that an unstated given. It's there, but they don't explicitly say it. Okay? Now, why might it be important to know the velocity at the highest point? Why would that be important to know? Because if down here is the initial velocity, up here is the final velocity. Now we have v initial and v final. Okay? All right, second thing to know. The time it takes for a ball or an object to go up is equal to the time back down to the same level, right? So obviously if the ball kept going, then time down would be greater, if it passed the starting point. But if an object starts at this level, goes up and back down, the time up and the time down are equal. Okay? All right, the third thing, which is why we don't shoot guns in the air. I mean, you just really shouldn't do that. You guys know that, though. Hopefully not many of you own guns, although probably some of you. I'm not the biggest fan of guns. Okay, anyway. So an object leaves with a velocity. So say we'll just use this, 8 meters per second. If this object leaves at 8 meters per second, with what speed will it return with? It's going to go up and then back down again. What will be the speed of the ball when it returns to the same level? 8 meters per second. But now it's going to be negative. Why negative? It's going down. Our sign convention for the vertical, up is plus, down is minus. Okay, so when it returns, it's going down at 8 meters per second. And by the way, remember last week we talked about speed and velocity? The 8 is the speed, and if you add a direction to that, then it becomes velocity. Speed is the magnitude of velocity. Okay, and there's actually a fourth thing. There's a fourth thing I want you to know. The fourth thing to know about free fall, and I can't believe I didn't type this on my list here, is the acceleration. Whenever an object's in free fall, we know that the acceleration will be equal to gravity. And gravity is equal to negative 9.8 meter per second squared. Why is gravity negative? It's down. Gravity is always down. And 9.8 frequently gets rounded to 10. Okay, so here we have a problem. A ball is thrown straight up with an initial velocity of 8 meters per second. We're going to find three things. And this is going to make you think a little bit harder than the last one. Find the maximum height that the ball will reach, the time the ball will spend in the air, and the velocity of the ball 1 second after being thrown. So I'll give you guys 5 minutes to work this out. And I'll give you the answers here. The maximum height comes out to be 3.3 meters. The time is 1.6 seconds. And the velocity of the ball comes out as negative 1.8. Those are the answers. So it'll take about 5 minutes. I'm going to delete all the text just so I have room to solve it. So we have the three questions there. Make some room. All right, so the first question was find the maximum height of the ball. And you know what? I'm also going to delete this. We don't need that. So the ball is thrown straight up in the air. The initial velocity is 8 meters per second. Positive because, you know, it's thrown upward. Up is plus, down is minus. That's our sign convention. And if we're solving for the maximum height reached, where does it make sense to put the final point, the final position? At the maximum height, at the top. So we are solving for the displacement from here to there. That is, let's label that X. X equals question mark. Now what else do we know? What's the unstated given here? There's actually two unstated givens. The final velocity, the problem did not explicitly say that. And then what's the other unstated given? The acceleration is equal to gravity, which is negative 9.8. And then time is also a question mark. We're not given time. Okay, so finding the maximum height. There is only one of the four motion equations where you can solve for the maximum height directly. What's the one motion equation that allows us to do it? The one that starts with Vf squared equals V initial squared plus 2ax. Now, which variable are we solving for here? X. We're solving for x. Now guys, since it's early in the year, the sooner you get into this habit, the better. Because students always want to put numbers in as soon as possible. How many of you would say that's true? Like, your preference is to put in the numbers into the equation as quickly as possible. That's kind of like the instinct that most kids have. Starting today, challenge yourself to do it the AP way. What graders want to see on the AP exam is they want to see you do the algebra first, then plug the numbers in. So you'll see what I mean here. All right, so what's velocity final? 0, so you just set that to 0, right? At the maximum height, the final velocity is 0. Now don't plug numbers in yet. Do the algebra. So what's x going to be equal to? If you do the algebra, you're going to get negative v initial squared over 2a. That's what the algebra would give. Okay? Now you plug in numbers. So all I did from here to there is just algebraic manipulation. Just, I don't think I need to show it. All right, so then this is 8 meters per second. V initial is 8. Make sure you square it. 2, and then what's the acceleration? Negative 9.8. Now what happens to these negatives here? They cancel. And we end up with a positive displacement, which makes sense because which way was the ball's displacement? From starting point here to ending point up there, was that a positive upward displacement or a negative downward displacement? It's upward. So the answer came out plus. All right, second question. Find the time, the total time in the air, round trip, the time up and the time down. I'm going to show you 2 ways to do it. The first way to do it is to solve for the time up. Solve for the time up, and what do we know about time up compared to time down? It's the same. So if you can figure out the time from the starting point to the maximum height, all you have to do is double it, and then you have the total time in the air, right? So let's do that way first. So I would go V final equals V initial plus AT. Now where's my final position here? It's still the maximum height, right? Up here is still my final. So what's V final? 0, so we can cross that to 0. And don't plug numbers in yet, do the algebra. T equals negative V initial over A. That's what the algebra gives. So then we got negative 8 meter per second divided by negative 9.8. And then this gives, and notice what happens to those negatives. They cancel. If you ever get a negative time, that means you made a mistake. Time will never come out negative, only positive. So this comes out as 0.816 seconds. That's the time up. So then we double it to get the total time, which is 1.6. And then just round to 10th place. Yeah?
When we're doing our homework and the problems, do you want us to use gravity as 9.8 meters per second squared? 9.8?
When you're doing the homework set, I would use 9.8 because that's what the textbook uses. The textbook uses 9.8, so when you're checking your answers in the back of the book, you want your answers to be right on. Yeah? I doubled it because the time up and the time down are the same. The 0.816 was the time up. And we're looking for the up and down. We're looking for the total time. Okay, I want to show you one other way you could have solved for the total time in one calculation. Another way you could have done it, and this is kind of cool, x equals 1/2 AT squared plus V initial t. So if we focus on the whole journey, the up and the down, so the ball starts down here, the ball starts there, goes up and back down again, and ends there. What's the displacement of the ball for the whole journey, up and down? It's 0. X goes to 0 because it starts and stops at the same point. So now look what you get. You get 1/2 AT squared equals negative V initial t. Now what happens to one of those t's? They cancel. One of the t's cancels, and you get t equals negative 2V initial over A. Notice this and this. What do you notice about them? Times 2, right? So you plug into this, and you're going to get 1.6 seconds. So you could have just done it in one calculation. Is this making sense? Okay, last question and then we're done. Find the velocity of the ball 1 second after being thrown. So just make some space here. 1 second after being thrown. So the VF equals V initial plus AT. So V initial is positive 8. Acceleration is negative 9.8. Don't forget the negative. Time is 1. So then V final comes out as negative 1.8 meter per second. Does it make sense that the answer came out negative? Yes, because which way is the ball moving at 1 second? Down. The negative is telling us down.